Good afternoon, everyone. Today we'll see the electrical and hybrid vehicles, the program elective in the E4 with the program code EEPE62. The course objectives and outcomes are like the students are able to learn the conventional vehicles and hybrid vehicles. So, what are the drawbacks of the conventional vehicles and how the electric and hybrid vehicles come into the pictures? What are the developments in the electrical and hybrid vehicles and hybrid electric drivetrains? So, electric trains like electric drivetrains, energy storage systems, energy management strategies. So, these are the few topics which we are going to cover in this syllabus. So at the end of the course, the students will be able to understand the models to describe the hybrid vehicles and their performance and understand the different possible ways of energy storage and understand the different strategies related to the energy storage systems. So coming to the introduction to the electric and hybrid vehicles. So this class, particularly this class, will develop the students' knowledge on history, merits and demerits of the electric and internal combustion engine vehicles, that is IC engine vehicles. So a brief history, the first demonstration electric vehicles were made in the 1830s and it commercially electric vehicles were available by the end of the 19th century. So the first electric vehicles of the 1830s used are non-rechargeable batteries. So with simple batteries, by the end of the 19th century, with mass production of the rechargeable batteries, electric vehicles became fairly widely used and those are available. An electric New York taxi from about 1901 is shown on the left side, on the right side. So the first car to exceed the miles per minute speed, that is 60 miles per hour, when the Belgium racing driver Camille Genati driving the electric vehicle known as Las Jamias Contenti set a new land speed record of 106 kilometers per hour or 65.7 miles per hour. So after that, the first car, this is exceed to 100 kilometers per hour. The electric vehicle was widely and it is available and also relatively reliable and started instantly, whereas internal combustion engine vehicles were at the time unreliable and it was smelly also, and it needs to be manually cranked engines to start. So the other main contender, the steam engines vehicles, needed lighting and the thermal efficiency of the engines was relatively low. So coming to the IC engines as well as the steam engines, both were showed as a drawback over the electric vehicles. By the 1920s, several hundreds, thousands of electric vehicles had been produced for the use as a cars, vans, taxis and delivery vehicles and buses. So however, despite the promises of the early electric vehicles, once when the cheap oil was widely available and the self-starter of the internal combustion engines was invented in the 1911, so the IC engines were proved more attractive option for powering the vehicles than the electric vehicles. Moreover, the specific energy of the fuels for the IC engines varies, but it is around 9000 watt hour per kg, whereas the specific energy of the lead acid battery is around 30 watt hour per kg. So this relative decline of the electric vehicles after 1910 because of the wide availability of the IC engines, advantages like self-start and more specific energy like here shown, Once the efficiency of the IC engine's gearbox transmission, typically around 20% for a petrol engine, is accounted for, this means that 1800 watt hour per kg of useful energy at the gearbox shaft can be obtained from the petrol. The example, if you see, with an electric motor efficiency of 90%, whereas the electric motor has 90% efficiency compared to the IC engine with 20%, but 90% efficiency only with 27 watt hour per kg of useful energy at the motor shaft end can be obtained from the lead acid battery with the same amount of the input energy. So to illustrate this point further, let us take that 4.5 liters, that is 1 gallon of petrol with a mass of around 4 kg will give a typical motor car range of 50 kilometers. So by filling the tank with 4.5 liters of 4 kgs, it will give 50 kilometers range. But to store the same amount of energy or to give the same kilometers, the lead acid battery needs a mass of 270 kg. To double the energy storage and hence the range of the petrol engine vehicle requires storage of a further 4.5 liters of fuel. That means if you want to double the range 100 kilometers, just we need to fill the tank with another 4.5 liters with a mass of 4 kg only. But coming to the lead acid battery, the vehicle requires an additional battery mass of about 270 kgs. So it is huge weight in the car. In practice, this will not double the electric vehicle range, as a considerable amount of extra energy is needed to accelerate and decelerate the 270 kg of battery and to carry it up hills. Because as weight is increasing, it will not double the range. It needs more energy to pull that vehicle or to draw that vehicle only. So to carry that vehicle only, that energy can be consumed. So to illustrate further, let us take the first figure. The vehicle with a range of about 50 kilometers, but tank contains only 4 kg, 4.5 liters in the fuel with a calorific value of 36,000 watt hour. Now, as this is petrol engine, the first figure, that engine efficiency is 20% only, and shaft energy obtained with the 20% is around 7200 watt hour. To get the same amount of 7200 watt hour at shaft in the electric vehicle, the second figure at the down left side. So the lead acid battery with a mass of 270 kg is required, volume of around 135 liters and energy of 8100 watt hour. Whereas the electric motor efficiency is 90%. Even the 90% efficiency, the conversion efficiency is high, but the weight is more here in this case. To increase the range from 50 kilometers to 500 kilometers, the right side figure shows, with first one is petrol engine with 20% efficiency. We required 45 liters with 40 kg with a calorific value of 3,60,000 watt hour. At the end of the shaft, we'll get the energy as 72,000 watt hour, whereas in the electric motor with 90% efficiency, to get the same amount of 72,000 watt hour at the shaft as output, we required 2700 kg with a volume of around 1350 liters, which will give only 81,000 watt hour. This is a huge weight in the electric car, which will obviously decline the energy, and it is not feasible for the electric vehicle to increase the range with this weight. So some of this energy may be regained through the regenerative braking. In the electric vehicle, generally we can regain the energy through the regenerative braking, a system where the motor acts as a generator in braking the vehicle and converting the kinetic energy of vehicle to the electrical energy. which is returned to the battery storage, from where it can be reused again. In practice, when the efficiency of generation, control, battery storage, and passing the electricity back through the motor and controller is accounted for, less than one third of or third of the energy is likely to be recovered. So a small amount of energy can be recovered or regenerated. As a result, regenerative braking tends to be used as much as a convenient way of braking heavy vehicles. Instead of manual braking, heavy vehicles can be braked by using this regenerative braking, which electric cars normally are as for energy efficiency. For lead acid batteries to have the effective energy capacity of 45 liters of petrol, a staggering 2.7 tons of batteries would be needed. So just to have that 45 liters capacity of the petrol engine, we need to keep the 2.7 tons of batteries in the vehicle. So another major problem. These are the problems to the early developments in the electric vehicle. Another problem that arises with the batteries is the time takes to recharge them. That means to charge the battery, it will take around hours of time. But whereas to refuel the petrol, it may take hardly 2 to 3 minutes, right? 2 to 3 minutes we can approximately fill the full tank, but or 5 minutes we can fill the full tank. The considerable charging time as well as the petrol filling time is a huge difference is there between this time. The recharge time for some of the new batteries has been reduced to 1 hour. Even though it is reduced to 1 hour, but still it is considerably longer than it takes to fill a tank of petrol. Yet another limiting parameter with the electric vehicles is, so batteries are expensive. Batteries are heavier as well as batteries are expensive. So this is likely to not to that means go for, it's not preferable to go with that expensive batteries. So that is also one of the limiting parameters. And with the expensive batteries, the limited range you can get it in that electric vehicle compared to the IC engine vehicles of the similar size of the vehicle. For example, 2.7 tons of lead acid batteries, which give same efficiency energy storage of 45 liters of petrol, would cost around 8,000 pounds at today's prices. So price will become more obviously when we are going for the more number of batteries with heavy weight. The vehicle weight will increase, again efficiency of the vehicle, all mile per hour range will decrease. So the batteries also have a limited life. Typically that may be 5 years, which means that a further large investment is needed periodically to renew the batteries. So batteries is recycling of the batteries is biggest problem. So the petrol vehicle can go up to 15 years. As per the government norms, we can use the petrol vehicle up to 15 years. By extending the life, we may go for 5 more years. When one takes these factors into consideration, the reason for the predominance of the IC engine vehicles for the most of the 20th century becomes clear. So that's why there is a clear decline in the electric vehicles in the end of the 19th century. Since the 19th century, ways of overcoming the limited energy storage of batteries have been used. But still, the first is supplying the electrical energy via supply rails, best example being the trolley bus. Since even though the drawbacks are there at limited applications and few places, the electric vehicle usage have been become popular, like trolley buses, even for handicapped people like that. So this has been widely used during the 20th century and allows quite non-polluting buses to be used in towns and cities. When the electric supply lines and buses can run from their own batteries, so that become complex lines in the cities, right? So it looks expensive, and moreover it looks ugly supply lines which are needed, and most of the trolley bus systems have been removed from the services because of the electric supply lines in the major cities. So nowadays, but we can go for wireless power transfer system. That's why modern inductive power transfer systems may overcome this problem. Without wiring in the main cities, we can use the electric charging of the vehicles. Early in the development of the vehicles, the concept was developed of the hybrid vehicles, in which the internal combustion engine driving a generator is used in conjunction with one or more electric motors. So hybrid electric vehicle means just to increase, to get both advantage, like electric vehicle advantage as well as the IC engine vehicle advantages. Hybrid vehicles have come into the picture. These were tried in the early 20th century, but recently have very much popular and it come into the picture. The hybrid car is one of the most promising ideas, which could revolutionize the impact of the electric vehicles. So there are many companies which were used and which came into this electric vehicle developments, and almost all the car companies nowadays, manufacturers nowadays, making the electric vehicle cars. So there is a considerable potential for the development of the electric hybrid, and the idea of hybrid shows the considerable promise for future development. So use for which battery electric vehicles have remained popular. Despite the above problems, there have always been uses for the electric vehicles since the early part of the 20th century. They have certain advantages over the combustion engines. Mainly, they do not produce any harmful gases or emissions in their immediate environment, in the cities or in the hospitals or in the peaceful environment. Secondly, that they are inherently quiet. There is no sound with the electric vehicle. This makes the electric vehicle ideal for environments such as warehouses, inside buildings, and golf courses where pollution and noise will not be tolerated. One popular application of battery or electric drives is for mobility devices for the elderly and physically handicapped. So, like the figure shows, electric powered wheelchair. So, this becomes popular because for small range of traveling, normally a 4 miles is quite sufficient, but longer range allows disabled people to drive along country lanes. So small shops or shopping malls like that, this electric vehicle or trolleys can be used, and they also retain their efficiencies in stop driving when an internal combustion engine becomes very inefficient and polluting. So this makes the electric vehicle attractive for use as a delivery vehicle, such as the delivery vehicles, trolleys. During the latter part of the 20th century, there have been changes which may make the electric vehicle more attractive proportion. Firstly, there are increasing concerns about the environment, both in terms of the overall emissions of the carbon dioxide and also the local emissions of the exhaust fumes, which help make crowded towns and cities unpleasant to live in. Especially the electric vehicle concept has come into the picture, and the more developments are doing because of the to reduce the pollution in the major cities, populated cities. There is no alternative way to reduce the population pollution. Only electric vehicle need to be introduced in that major cities. Secondly, there have been a technical developments in the vehicle's design, improvements to rechargeable batteries, motors, and controls. All these advancements are pushing the electric vehicles into the market, and moreover, cost is also considerably reducing. In addition to the batteries, which can be refueled, and fuel cells, first invented by the Grove in 1840, have been developed to the point where they are being used in electric vehicles. Even fuel cells vehicles also one of the major concept. The environmental issues uh, may well be the deciding factor in the adoption of the electric vehicles for the town and city uses. So leaded petrol has already been banned, and there have been attempts in some cities to force the introduction of zero emission vehicles by setting some target like by the end of the 2070 or 2050 to reach that zero emission goals in few cities, major cities. They have banned the petrol vehicles or diesel vehicles. Even in India also there is a diesel vehicles may be zero in particular year, like that the central is has announced, right? So in this way, to reduce that or to achieve that zero emission state, the cities in the major cities, so the electric vehicle have become more popular. The fairly complex nature of the regulations in the state or in the country, in few countries, led to the very interesting developments in fuel cell, battery or hybrid electric vehicles. Electric vehicles do not necessarily reduce the overall amount of the energy used. Obviously the electrical vehicles do not reduce the overall emission, but they do away with the onboard generated power from the IC engines fitted to the vehicles and transfer the problem to the power stations, which can use a wide variety of fuels and where the exhaust emissions can be handled responsibly. Instead of at the major cities, the pollution can be handled at the power stations responsibly by taking the measures to generate the electricity. That electricity can be used to charge the electric vehicles. So where fossil fuels are burned for supplying the electricity, the overall efficiency of supplying energy to the car is not necessarily much better than using a diesel engine or the more modern highly efficient petrol engines. However, there is more flexibility in the choice of fuels at the power stations. Like we discussed, also some or all the energy can be obtained from the alternate energy sources also. To generate the electricity, no need to go for fuel consumption like coal burning. There is a chance for alternate energy sources also, hydro, wind, tidal, which would ensure overall zero emission. Of the technical developments, the battery is an area where there have been improvements, although these have not been as great as many people would have been wished. Commercially available batteries such as nickel cadmium or nickel metal hydride can carry at best about double the energy of lead acid batteries compared to the lead acid batteries. So this even G Pro batteries or nickel chloride batteries give almost 2 to 3 times energy. So the developments are there in the energy storage also. So this is a useful improvement, but still does not allow the design of the vehicles with a long range. So in practice, the available rechargeable batteries with the highest specific energy is the lithium polymer battery, so which has a specific energy of about 3 times the lead acid battery. This is still expensive, although there are signs that the price will fall considerably in the future. Even though the price is high at this moment, but it will definitely fall like solar panels at the initial stage. So zinc air batteries have potentially 7 times the specific energy compared to the 3 times. It is 7 times. Zinc air batteries will give the 7 times specific energy of the lead acid batteries, and fuel cells shows considerable promise. So with these batteries or advanced batteries, again if you compare with the petrol vehicles, IC engine vehicles and electric vehicles, for example, to replace the 45 liters of petrol, which would give a vehicle range of 450 kilometers, a mass of 800 kg of lithium batteries would be required. An improvement of 2700 kg of lead acid batteries, but still a large and heavy batteries. Initially by using the lead acid batteries that require 2700 kg. Instead of that, the weight has reduced to around 800 kgs with the lithium batteries, but still that weight is high only. Have been increasing attempts to run the vehicles from the photovoltaic cells. So even photovoltaic cells are used continuously to charge the batteries. Although solar cells are expensive and limited power 100 watt per meter square of cells typically achieved a strong sunlight, they may make some impact in the future. The price of the photovoltaic cells is constantly falling and efficiency also increasing. So in this way, This becomes useful and particularly recharging the vehicles while vehicle is running, as at remote stations also it is possible to charge the batteries. These are the development towards the end of the 20th century. In the 1991, the commercialization of the lithium batteries have come into the picture, whereas Nissan has developed in 1996 first EV based vehicle, and again the Nissan has developed with 93 miles per 30 minutes with 24 kilowatt hour pack of battery has developed. The same Nissan has developed 93 miles with 30 kilowatt hour pack has developed. In 2016, the mileage has increased to 144 miles per 30 minutes with 31 kilowatt hour pack batteries pack, whereas Kia in 2017 has developed 33 kilowatt hour pack with more mileage like 170 miles per 30 minute. In 2018, Jaguar has developed 90 kilowatt hour pack with 153 miles per 30 minutes. See here, when the watt hour package is increasing, the weight is increasing. When weight is increasing, obviously the miles hour per minute or mile per hour need to be decreased. But here if you see the battery size considerably, they have reduced to increase the miles per hour. That's why even the watt per hour, kilowatt per hour has increasing, the miles per hour also they are increasing by reducing the weight of the car. In 2019, Audi has developed 95 kilowatt hour pack with 183 miles per 30 minutes, whereas Tesla has developed 246 miles. This is a great development in this EV stage. So 246 miles per 30 minutes with 100 kilowatt hour 100 kilowatt hour pack. So in the future, in the nearby, the 300 kilowatt DC power and with 250 miles per 15 minutes only. That means the range of miles is increasing over the years to reach to the more people and to develop and to commercialize the vehicles for the wide usability. So upon the completion of this class, the students will be able to compare the history of the electric vehicles and IC engine vehicles. So these are the references where the material has prepared. All.